What's happening, guys? Mr. Rouge here, and today we're talking about this beast of a word. It's pronounced nucleo. Before we get into what this is, let's go ahead and break this word down. So nucleosynthesis is broken down into two parts. We have the first part, nucleo, which is referring to the center of an atom. Okay. The next part of this word is synthesis, and that suffix synthesis means to make or create. So in nucleosynthesis, we are going to make new nuclei in atoms, okay? In nucleosynthesis, we're going to create new nuclei in the center of an atom. So before we get into that, let's take a look at this periodic table. This periodic table is all of the different elements, and all of these different elements literally make up all the matter that we see and that we know, okay? And remember, in biology, the specific elements that we're going to focus on are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Okay, so that's why we're talking about this. When we study biology, you might get the question, where does the hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur come from? In addition to everything else, where does all this other stuff come from that makes up all the matter that we know and that we see? And that's what we're talking about today. How did we get all of these varieties of atoms, especially the Schnapps atoms, okay? So before we get into how did we get this, these different atoms or different elements, we're gonna look at briefly how to read one of these little boxes in the periodic table, okay? So first, number one, what makes every element different? What makes them all different from each other? And the answer is simple. The answer is, it's the number of protons in the nucleus of the atom. Okay, so here we see this word again, nucleus of an atom in the center. So the number of protons in the center is what makes each element different and unique. Okay, so when we talk about hydrogen, hydrogen will always and forever have one proton in the nucleus. And we show that on the periodic table. If we go back to this picture, you see all these different elements have different numbers in the top corner. That's the atomic number. And what the atomic number is telling us is how many protons they have, okay? If this number ever changes, so let's say hydrogen gets 2 protons, it's no longer going to be hydrogen. It's going to be helium, okay? So the number of protons is what determines the element that it is. If that number ever changes, it's no longer that element, it's something different, okay? So let's process this real quick. Hydrogen has 1 proton. Helium, so this is hydrogen on the periodic table. Helium right here has, how many protons it have? Has 2. We can see by this atomic number. How many protons does carbon have? So scan this image real quick and tell me, how many protons does carbon have? Carbon has 6. You can see that right here. Carbon has 6 protons. How many protons does oxygen have? Look for the atomic number. Oxygen has 8 protons, and the atomic number is also 8. How many protons does iron have? Look for Fe, iron. Iron has 26. Iron will always have 26, okay? What's the atomic number of nitrogen? Well, the atomic number is right here. The atomic number of nitrogen is 7, and that is the same number of protons that nitrogen has. Okay? All right. So let's talk about the start of everything, the start of where did we get all these atoms from? Well, we have the Big Bang, okay? So in the Big Bang, we have everything that we know into existence in a single point, whoops, not that, single point like that, smaller than the head of a needle, okay? And this is 13.7 billion years ago, and all of a sudden there's expansion. Everything, all the space and time starts to expand, and the temperature of the universe at the time is so small and it's extremely hot. We're talking like billions and billions of degrees Fahrenheit, okay? Well, as the universe started to cool, there was only 3 elements. There was only 3 types of atoms in existence. It was primarily hydrogen, helium, and then very, very small amounts of lithium. So if we go back to the periodic table, let's take a look at where they are in the periodic table. We have hydrogen, we have helium, and then lithium is right here, okay? So one atom had 1 proton in the nucleus, one had 2 protons in the nucleus, and lithium has 3 protons in the nucleus, okay? That's all there was in existence. We didn't have these other varieties of elements yet, okay? So that's it, that's all there was. So what started to happen was all of this mass of gas, of hydrogen and helium gas, they started to pool together, okay? In this picture right here, they start to pool together. Why did they pull together? Because there was so much mass, gravity was forcing these gases inward, okay? Well, we know gas likes to dissipate. Gas likes to spread out. Gas naturally wants to do this, wants to move outward, okay? So we have these two opposing forces. You have gas pressure forcing out, then you have gravity forcing in, and gravity wins. Gravity overpowers the gas pressure, and then that gas starts to get hot and hot and hot, and everything starts to circulate and move. Well, what ends up happening is there's so much movement and there's so much heat. It creates such a hot, dense core that the nuclei, okay, the nuclei, let's say if this is our atom, the nuclei start to hit together and they fuse and they gain more protons. Well, if it gains more protons, that element changes, okay? So let's pretend this is 1 proton. That's hydrogen because there's only 1 proton. If it gains a second proton, if another atom smacks into it and that proton fuses to the nuclei, that's no longer hydrogen. That would be helium. And if that gains a third proton, that's no longer helium. That would be lithium. Okay, so it's in stars that these protons are fusing together. They're hitting together and they're fusing. And when they fuse, they start to form these other elements. Okay, they start to form these other elements over here. And this is where we get all of the different elements, and especially the elements that create living things. This is where we get schnapps from. Okay. Okay, so what ends up happening is in this star, you have the lighter elements. You have the lighter elements like hydrogen, helium, they form the outside of the star. As those protons fuse together and form heavier elements, those heavier elements reside closer and closer and closer to the core, okay, to the center of that star. So as we get heavier and heavier elements, they fall closer and closer to the center. Now, stars are made this way. Let me go back to this right here. Elements are made in that way up until iron. Iron is the heaviest element that will be made in a star that way, okay? That's the heaviest until it explodes. If it explodes, then you can get heavier elements. But the heaviest element that you'll find in the center of a star is iron, okay? Right here. Iron in the center, okay? Go ahead and put this bad boy on pause, and that's the last set of notes, and I'll catch you guys next time. That was nucleosynthesis, and that's how heavier atoms are made up until iron. I will catch you guys next time. Later.